We're going to use quadratics to solve problems with triangles. So, we have a triangle here. I've condensed the word problem into a picture essentially for you. The word problem said that one of the legs of the triangle was a centimeter longer than the other. In other words, we have one side of a triangle, and the other side was 1 centimeter longer, so that would be x plus 1. And the hypotenuse is 9 centimeters longer than the first leg. So the first leg being x, the hypotenuse is x plus 9. Great, I have a relationship with two legs and a hypotenuse. What formula do we already know about right angle triangles that we might be able to use to help solve this? Justin. Pythagoras Theorem relates all three of these legs of a triangle together. Pythagoras Theorem goes that a squared plus b squared is equal to c squared. And what does c squared stand for? Hypotenuse, right? The longest side. So this would be our c. The a and b can be either of them. So we'll call this guy a and this guy b. Okay. And we're going to replace a, b, and c in this equation with our sides. So a being x becomes x squared. B being x plus 1 becomes x plus 1 squared. And c being x plus 9 becomes x plus 9 squared. Okay. I now have three squared numbers. I want to actually distribute this. I'm going to expand and then simplify. Well, this will become just x squared. This actually becomes x plus 1 times x plus 1. When we have something squared, it means we're multiplying the base by itself twice. We'll have to do the same on the other side. We then use our distributive property. So the x has to go by both terms and the 1. We're then left with x squared. X times x is another x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. On the other side of the equation, we distribute the x and the 9. We'll get x squared, 9x plus 9x plus 81. Now, remember, in order to solve a quadratic, what do we need the entire equation to be equal to? 0. So I'm going to make every term come to the left side of the equation, or right side, whatever you're more comfortable with. And I'm going to have a 0 on the other side. So I'm going to highlight the left side of the equation numbers in blue, and I'll do the right side of the equation numbers when I bring them to the left in red. You'll start to see what I mean by this. So our left side of the equation, I am going to, actually I'll leave them as they are right now. X squared plus x squared plus x plus 1. Now, the red terms are these four terms over on the other side. The x squared will become a negative. The 9x will become a negative. The other 9x will become a negative. And the 81 will become a negative. These will all be equal to what? What will this be equal to? Perfect. 0. I then need to collect like terms. Our squared terms will all combine. Our x terms will all combine. And our constant terms, I need another color, we'll do black, will all combine. So our squared terms, x squared plus x squared minus x squared. It's just going to be 1x squared. Our x to the power 1, so x plus x, 2x. Minus 9x, negative 7, minus 9 again. 16. And finally, 1 or positive 1 minus 81. Sorry, not plus, you're right, negative 80. I now have what form of a quadratic? That's right, we have a standard form quadratic. We might be able to factor this. Let me think quickly. May take a while. So what formula do we want?
Quadratic.
Okay, so I've done quadratic formula a couple times for you. We're going to try to put this right into quadratic formula quickly. So x is equal to negative b. Well, we have negative 16. What does that become? Positive 16, right? Because this term's already negative, and we have to turn it negative. So our b term being 16, plus or minus, what is negative 16 squared? 0.
256.
256? Perfect. So 256. Now remember, this is minus 4ac. So negative 4 times 1 is negative 4 times c. Negative 4 times negative 80 is positive. Anyone know?
320.
Positive 220. Very good. All divided by 2a. What's our a term? 1. So 2 times 1 is 2. 16 plus or minus the root of 320 plus 256. Great. Anyone going to have a root for us there? Is it 24 right on? Great. 16, is it 24? Yeah. Plus or minus 24 divided by 2. We then have to do what? Split this equation. 16 plus 24 divided by 2. And 16 minus 24 divided by 2. 16 to 24 is 40 divided by 2 is 20. 16 minus 24 is negative 8 divided by 2 is negative 4. Is that right? Great. We have two answers. 20 and negative 4. Well, let's try to make sense of these. Let's go back to the original here. Can one side of this triangle be negative 4? No, we can't have a negative distance for a triangle. So negative 4 does not make sense in this question, which means negative 4 is not an answer. We would take negative 4 away. Even though we get two possible answers that fulfill the equation, logically it doesn't make sense for us. We don't measure triangles with negative values, right? So that's no good. That means we must have a triangle that's 20 centimeters. If this one's 20 centimeters, how long is this side? How long is the hypotenuse? 29. And if we really wanted to check, we would plug these values into our Pythagoras Theorem. It would end up being true. Okay? So there we go. That's an example where one answer is not logical. We have to think about what we've done and make sure it's